Yep, hello everyone and good evening. In this talk, I will talk about reactive state management using Jetpack components. And as Balazs actually mentioned, I will indeed talk about process that as well. Because what is the problem we are trying to solve? Why do we need Jetpack libraries, or at least how are they trying to help us? First thing and most important thing, in my opinion, is to consider that uh, when the application is backgrounded, then Android can kill it at any time. And you can return on any screen at any time as if it was the first application in the app. The first window in the app. This means that anything that was previously loaded will not be loaded. It will either be restored from save instance state, or it will be like erased forever. And when you have your state representation, then you also want to asynchronously load data based on that. And this data should be kept across configuration changes. But as previously mentioned, you need to consider that this is not loaded yet. There is always a case when this is not available yet. And where reactivity comes in is minimizing the number of bugs by minimizing the number of moving parts, like things that can change without expecting them, like modifying an object that nobody is observing but others depend on its values. To prevent these sort of mistakes, we can rely on reactive design. And in that case, our mutations should always be controlled and they should always be observed so that whenever there's a change that someone cares about, they need to be able to know about it. Therefore, first and foremost, how do Android apps actually work and why this is a problem that we need to solve? So imagine an application that has three screens, and one of them is a splash screen, the next is a list, the next is a detail. And you would assume that your splash screen is the initial launch activity or launch fragment, splash fragment is the first screen that shows in your application. And after 1 second, you go to the list. But there's a common scenario when people think that this is the first screen, this will always show, and they can preload data, for example, but that's not the case. You can easily end up with the user putting the application in background on the list screen. Android kills it entirely, and when you return, the list is the first thing you see. The Splash never loaded anything. So if you make assumptions about how Splash definitely had to run, that's not true at all. There is no guarantee that this happens, and this is actually the cause of many null pointer exceptions in a lot of code. And you might even end up on the detail screen as the first screen. So if you, for example, wanted to like share the selected item from the list screen to the detail screen, like with a shared view model or so, then there's no guarantee that the list is showing and that any property that is shared in a superscope, like either a singleton or a shared view model, although that can be made to work, that this actually happened. Your application is starting from zero, but it launches on the detail. And when you press back, you will go back to the list. And in comparison to this previous one, the user might not actually quit the app. Like they really might just put it in background and that's it. A lot of people actually quit the app that way, that they never finish. They just run to process that. So even the core application quality guidelines say that when returning to the foreground, the app must restore the preserved state and any significant stateful transaction that was pending, such as changes to editable fields, game progress, menus, videos, and other sections of the app. If you want to test your app for process that, what you can do is put the application in background with the home button on the device, then press the terminate application button in Android Studio, and when the app is backgrounded and Android Studio terminates it, then if you restart it from launcher, it will be exactly as if Android killed it for low memory. There were a few Android Studio versions where the initial launch from Android Studio would, even if you put it in background and terminated it, the next launch would not be after process that, and this kind of was at like 4.0-ish, so that was strange. But in that case, what you could do is launch the app, terminate it immediately, launch it from launcher, and then do the put in background with home, terminate, and restart from launcher, because then it would always work. For apps that you don't own, you can actually test if they behave correctly. Using this fill ROM memory application. You press fill full ROM, and eventually everything on your phone will just be killed by Android. It was much faster when I didn't have 4 gigabytes of RAM, but I still experienced process that even without this application. So yeah, as I previously mentioned, but it's worth reiterating, there are a few common mistakes that pop up every now and then when people don't really expect how Android works, that any screen can potentially be the first screen to show in the app. If people try to share data or state or anything really with static variables or singletons, then you cannot really expect a prefetch to stay in in memory, because the entire application dies, all static variables are nulled out. So you cannot prefetch like this and expect it to show immediately. That's just not how it happens. If that's what you need, then there's the arguments bundle and saved instance state bundle, but that has a limited size. So you probably just want to optimize for the case that, yes, there is a moment when your data is not yet available. There's also a common mistake where people don't use viewModel.init for data loading for some reason. Instead, they try to use onViewCreated and then say that if the save instance state is null, then ask the viewModel to load data. That is wrong. It will show an infinite loading dialog forever. This will not run after process that. So this assumption, it shouldn't be done. It will just break your code. And one more thing that I see very, very often is trying to hold a reference to a fragment that you create with new fragment and expect that it's not recreated by the system, but that's not really something you can assume. For example, in the case of the original pager adapter, which is now deprecated, and there's ViewPager too, but there are still cases where fragment pager adapter is completely reasonable to pick. I often see people trying to add fragments dynamically and then just return that fragment instance from getItem because they want to keep a reference to this fragment in the activity and talk to this fragment from the activity while it's also being shown by the view pager, but that's not how the view pager works. That's not how the fragment pager adapter works. So if you create the fragment inside getItem, then it will be correct. If you pass it in from outside, then you will have problems because the view pager not only generates an ID for this fragment that you added, but well, it is added. So added fragments are recreated by the fragment manager. And so any fragment that you would create yourself in the activity will never be displayed after process that. So you will have like these fragments that are not used and the ones that are managed by the system, and they will be out of sync, and you will get null pointer exceptions if you make any assumptions about the fragments created by you being correct. You should always try to find if a fragment is created using find fragment by tag, assuming you're not using navigation, because in that case it's a bit different, but we will see that later. So how do you detect if process that happened? In an activity, you can do saved instance state is not null, and the last non-configuration instance is null. So this would mean that there is state to restore after process that, but there has not been any saved non-configuration instance. This mechanism isn't really available to us anymore, but Google uses it, and it's part of the lifecycle callbacks on retain non-configuration instance. So this is a reliable way to detect it. Or application globally, you can set a static flag that yes, restoration has happened, and that helps. Okay, so what we need to know about though is that there are multiple ways to store the state. Jetpack provides us with viewModel, which is an in-memory cache that survives configuration changes. There's saved instance state, which survives for the duration of the process, and when it's recreated, then it's passed to it. But if you task clear the application, or you force stop the application, or your phone restarts, then saved instance state will be lost. So there is a certain aspect of durability that we can expect from save instance state. But for example, quitting the app and it should remember, no, that actually goes in persistent storage, which in this case, Google provided these 3 examples, but it's really 4 examples, because, 4 options, because the disk is locally available and you read it asynchronously, but the network is not always available. So sometimes you are like in a tunnel in London, or you have airplane mode on, or you are on a plane. Like in that case, you definitely don't have access to the network, but you might still want to use the app. So what do we need to persist across process that? Navigation state is managed by the system. Even originally without navigation, you would use empty constructors and intent extras or fragment arguments, and those would be preserved by the system. Now, the Jetpack navigation arguments that are passed are retained along with the nav backstack entry, which receive the arguments and then propagate it to the fragment itself. That is also managed. And screen state is partially managed by the system, but not all of it. Views with IDs have their state persisted. There's a caveat to this though, which is that if a view has the same ID as another one, like for example, you use a compound view group, you use include, for example, then views can have the same ID, and the last view will overwrite the state of the ones above it. So this is actually not a foolproof mechanism, even though you would think that it is. In that case, you have to freeze the state management of the child and manage it by the parent, which has a unique ID. So that's something to consider, and it might just be easier to just make sure the view is not restoring its state and pass it in from the view model. That way you don't get surprised by this. Complex state like recycler view selection is not persisted automatically. You typically create a hash set that stores the selected IDs, and you persist that in order to detect which items are selected and which one is not. There is a recycler view selection library which is actually called that. I think it's been beta for a long time, and what it primarily handles is touch dragging multi-selection. That actually does handle supposedly the restoration of the selected items, but it's a bit tricky to integrate into a fragment. So, and I haven't really used it much. I tried it once. What's also important is that sometimes you see people try to add views dynamically into a linear layout, for example, and they're just like, add view. But if you rotate the screen, even just rotating the screen is enough, to be honest, you see that it disappears. So you want to be able to have a model that describes what views should exist instead of just one-off events adding them. What shouldn't be persisted? Data. You can save data on local storage, like for example you can use room, or you could originally use shared preferences for the simplest cases, because bundle has a size limit and you don't want to go over that. The size limit, if I recall correctly, is 1 megabyte. So if you are trying to save 100 items into a bundle or even a bitmap, that will not work. That will explode. In that case, you actually have to save the bitmap to a file and reload it from there. Data should be fetched asynchronously of the UI thread based on the current state. And what also shouldn't be persisted is the transient state. So for example, you're loading data and you have a boolean that says is loading, but that is tracking the current state of an operation that is effectively a side effect. So if you persist that and afterwards you don't try to restart that process, you can immediately end up with an infinite loading dialog. Example for showing and restoring the state the old way. These, in my opinion, are the most important callbacks in the Android components that are provided, either activity or fragment really. onCreate and onSave instance state. This is one of the most essential lifecycle callbacks that the OS expects us to handle correctly. And in this case, we would just save the selected states into the onSave instance state bundle, and then when it is available from the save instance state, we restore it from there. Yes, so loading data, it should be asynchronous. I have mentioned this before, but when do you do that? You either do it in something like viewModel.init, which is the initialization, not in onSaved instance state equals null inside a fragment. That will not work. Or when observed. And this is key and important because, for example, why would you want to keep reloading data if you have something that is polling for some reason? You probably don't want to do that, but you might, and you probably don't want to keep polling data that you don't need. So in that sense, you can instead detect when the data source is being observed and only refresh this data set when changes have happened. And what's important to us is that state can be used as the basis of loading the data using a transformation chain. So there are operators that we can use in all these reactive frameworks, but it effectively really just means that whenever there's a change, the previous operation is cancelled and the new one is kept. Or in some cases, they're just all handled and you receive them either unordered or in order. There are various operators for this, but for state management you generally use switch map, which only retains the latest value, and flat map latest, which is the exact same thing but in flow. How can Jetpack help us? Well, with surviving configuration changes and storing the data, we can use viewModel. It is kinda the only way now to handle keeping data alive across configuration changes without using something that's deprecated, because you used to be able to use last custom non-configuration instance, but that's deprecated. You could use retained fragments, but that's also deprecated, so only viewModel remains. Lifecycle aware data loading. So you can use live data and lifecycle observers to propagate whether the observer is actually interested in receiving events. For persistent storage, you can use Room. What's important is that it provides us with observable queries. So we can expose flowables or live data from Room, and whenever there's a change made to the database, we are notified of it, and we can track it without us manually having to know that, hey, we made a change to the database, I will reload the data. No, the Room database will tell us that someone modified me, here's the new data. That is significantly less error prone because you cannot forget it. Room handles it. There's also data store, which is NoSQL in a way. Like, it's really just storing either using protobuf. Actually, it's using protobuf to serialize data onto the device, and it exposes flows, so it also actually notifies us of changes made to it. There's paging, which honestly could be its own talk. At that point, it might be easier to just check out coding in flow tutorials. But what paging does is it does multiple things. What it does is that it exposes the data set. If it's too large, like for example, there you have 3,000 items and they change reasonably often, and you don't want to reload all 3,000 each time because it would consume a lot of memory and time, then instead paging can manage that you only want to load 50 of them or 100 of them. And as you scroll up and down, the new items are loaded seamlessly in the background and appended to the page list provided from the page data source. And what's also important to us is background job processing, because you don't know when network is available. So if your application needs offline caching, then you generally don't assume that I can load the data now. Instead, what you do is pre-cache, but using the work manager when network is available with one-time work requests, and the data is saved And when network is available and you manage to save it, then room will notify you. What's also helpful to us is the save state registry and the save state handle. This will be the basis for reactivity. Jetpack also helps us with connecting the UI to the state model, which we can preserve across configuration changes and process that. You can either use data binding, or technically this is what Compose does. That's also beta and will be mentioned a bit later as well. So you can scope data and state between screens and pass arguments using Jetpack navigation. What's interesting is that you can nest navigation tags, and each navigation tag and each destination really has its own nav backstack entry, which can be used with save state handles. So it would be shared state between screens, but it has automatic state persistence support. And there's also one more Jetpack component that's important to us, which is health, because it helps us piece together all of these things. So view model is stored across configuration changes in a view model store, and both the component activity, so technically app compat activity, fragment, and nav backstack entry are view model store owners. These view model stores are preserved by Jetpack across configuration changes using the non-configuration instance mechanism. They have their own lifecycle, so when you finish the screen, you back away, then onCleared is called, and this is used to manage the view model scope, which automatically manages coroutine lifecycles. This is where all state and asynchronous operations should go in the case of Jetpack. Originally, you would use the view model provider directly, and you would pass it the view model store owner and the view model provider factory. These were required because the view model store itself either already contains the view model or it doesn't. So when it doesn't, it needs to know how to create it. But if it already does, then this is the method that lets you get it from the view model store. So what's important here is that if you're using Jetpack view model and you're just creating it by hand, then you should not do that. You need to use the view model provider, otherwise it won't work. And afterwards, KTX provided us with helper functions, which in most cases you would just use the default arguments, which is this, and the default view model provider factory, which is also this, as fragments are OS, they implement has default view model provider factory, and that allows Jetpack to provide default behavior, which makes sense. Like, for example, providing the save state handle and also providing the application instance to an Android view model. But what's important here is that this is a lazy evaluation. We will see that later, that we should resolve this in onView created. Okay, so lifecycle KTX provided us with many things, not only just live data and mutable live data, but also mediator live data, which is used to combine these live data values. It was possible to create custom operators that would, for example, if any of the underlying live data changes, if any of the sources change, then you get an event in your mediator live data, and you can set the value of it or you don't. It's up to you really. You could define any operators, but the most important thing you could do with it is combine multiple live data to become a single emission. What Google also provided is the live data coroutine builder, which allows you to create a live data in which the activation state, because live data has on active and on inactive depending on whether it has at least one active observer or not. Well, the live data coroutine builder, it executes a job if there is at least one active observer, and it terminates the job after a given timeout if there isn't. And they also provide us with flow integration, which allows us to convert any live data into a flow. And what's the other end of the puzzle? The other end of the puzzle is the lifecycle scope, which allows us to observe flows and execute coroutines only when the given screen, I mean lifecycle owner, is at least started. So only when it's active. If it's not in foreground, or if we navigate it away, then these coroutines can either be cancelled or suspended. And for these, Google provides us with either the launch when started method, or it now provides the add repeating job, which is, I hear that name subject to change as it's alpha. It's one of the newest things that Google released, which allows cancellation of the coroutines rather than just suspension of them. What's important to know, or at least I think it's important to know, live data, you can only write to it from the UI thread. Because it's thread confined, it's effectively thread safe. So you can always guarantee that when it is read from the UI thread, it's always going to be a correct value. However, as a result, when you're using mediated live data, for example, then yes, the actual write into the live data has to happen on the UI thread. However, it is still possible to execute background logic thanks to the new live data coroutine builder. We can use with context and emit the value when there's a change, and it would be executed on a background thread. There is actually a valid reason not to use live data in a repository, but not this one. Why you would probably want to not use it is because you can use dot value on any live data, but values are only propagated between them if you chain them. If they have an active observer, so you can end up with like invalid state, and that's not good. So at that point, you might actually want to use flow or observable or something similar. Room exposes observable queries, and you can either use live data, which uses the computable live data under the hood. It evaluates the query if the data set has been invalidated, but it also works with flowables and observables and flows. Work Manager, it also provides us integration with all of these tools. And safe state handle, I mean, safe state registry is actually not used that often directly, but the safe state handle uses it. And what's interesting about it is that it essentially lets you hijack the onSafe instance state call, and you don't need access to the bundle itself that you are given from that callback. You can instead register for a given key and save your state there. And you can also consume it, but it's called consume because when you call it once, then you will not get it again later. What's important to us, what's really important to us, is the view model safe state integration. The safe state handle allows us to save state that is inside the view model. So it gives us get and set, but you don't really use those, you use get live data, because that under the hood stores the current the current state, and when the view model is recreated after process that, then this is reinitialized from the safe state registry. But when it's not yet state restoration time, then it is initialized with the arguments by default, and it tracks these changes and notifies us of changes using this live data. Saving state live data is a mutable live data, so you can write into it directly like that. And you would have to use the abstract safe state view model factory for it originally, but that was kind of tricky. Hilt will help us with that. Data binding. I personally recommend using view binding instead, but data binding does intend to solve a particular problem. It's you can observe from XML that a given value has changed in the state model, and you can use either one-way bindings or two-way bindings. One-way bindings notify you of changes when the view model state is changed, but the two-way binding, when you modify the view, that would also directly write into the view model state from outside, which can be helpful even though it can look hacky. You need to expose mutable live data or observable field or mutable state flow from outside. But if it writes it directly, then it also keeps it in sync, and this can be useful for forms. They also provide binding adapters. These specifically were designed to expose properties of the view as observables. There is a misconception that these were designed as XML extension functions, but that only creates multiple ways to change the same property, which actually can cause a lot of bugs. You can also, I've also seen cases where people hide state in the view tag just to access it in the binding adapter. You probably shouldn't do that. Jetpack Compose is relevant because the Kotlin compiler plugin that makes it all work is effectively doing something very similar to what the generated code in data binding does. So you have composable functions, they each have arguments, and whenever these arguments change, then those who depend on these arguments are recomposed and reevaluated. But as such, you shouldn't run side effects directly in the where you're composing the views themselves. You only want to invoke the view that you expect to exist in that given state. And with Compose, you can actually end up with screens like this. The screen, you would provide the data from outside, you would provide the change handlers, and the view itself does not need to know anything about what happens when this change callback is called. You can move out all behavior, and you don't even need to know the view model, so it can technically be reused elsewhere as well. Navigation, Jetpack navigation was created to make it simpler to use one activity for the whole app, because the activity represents a window for the app itself. People used to believe that it's a screen, but it's really a window technically, and inside it you can swap fragments. Theoretically, if you use Jetpack navigation, it would be possible to make it so that the activity itself is just the layout passed to it, and it would contain the nav host fragment, and that would contain all of the app. You would not need to write anything else in the activity. This, of course, is idealized, but it is theoretically possible. It tracks the navigation state, handles the argument passing, and it defines scopes for each destination, which are the nav backstack entries. And we have Hilt, which generates components for each common Android type, like activity or fragment. There's also the scope in between the activity, not in between, above the activity retained scope, which can be configured. You define modules that can install your dependencies into them, and Hilt resolves them. And this integrates with viewModel and safe state nicely. In fact, we will see that with Jetpack, just Jetpack, we can do something fairly complex in just 2 slides. So we would add the Hilt Android app on our application class. We would add Android entry point on the activity. We have the fragment container view that gets the navigation graph, and the activity does nothing else at all. And on the other end, the fragment is also marked with Android entry point, which allows Hilt to override the default viewModel provider factory and uses Hilt instead. So that way, Hilt can perform dependency injection for viewModels, and it also can provide the safe state handle even without assisted injection. We use view binding here, and we also resolve the view model immediately in on view created. Otherwise, you can get nasty bugs if your first resolution is on a different thread. And the view model is marked with Hilt view model. It can get any dependencies from the singleton and the activity retained scope, if I recall correctly. And there's also a view model component that directly can provide things to the view model. And in this case, we would use the safe state handle to get a live data, which could potentially be an argument originally, but it could be changed later. And we use that as the basis to load our data from the database and expose it as a flow, so that when the port is changed, then we get a notification for it. And we store it, we cache it with state into the view model scope, which would keep the state alive until the view model is cleared, which is when the view model store owner is cleared, so when the fragment is removed or the activity is finished. So we're getting to the to reactivity actually. We actually did that here, but what are we trying to do here? We want to minimize the moving parts, so no mutation can happen without being notified of it. And this means for us that If there is mutation that we cannot be notified of, that is a problem because it will cause bugs. And the state synchronization is idempotent. So that means that instead of like observing the state and then add view, add view, add view over and over again, you would just like set the items to the recycler view adapter, for example, and that way it is idempotent. It doesn't matter how many times it's called. If you get the same state, you get the same result. It doesn't change over time. So don't expose an array list in either a flow or a mutable live data or an observable. Just don't. And what's also important is do not expose array lists as the return type of a public function, for example, because that can be mutated and you cannot know if this is internal state of the class. And something that also can cause a lot of bugs is using mutable variables inside parcelable objects. Instead, use the read-only collections in Kotlin, and even in Java, but maybe even in Kotlin, you can instead copy the original list and then return an unmodifiable list of this copy, so that the copy itself will not change because it's not the original that is mutable inside the state. But it is also not mutable from outside. So this prevents us from misusing the list and making changes that we don't expect. And we should use vals instead of parcelables. Once we have this, and we are notified of changes, then you can imagine your state as the values in a spreadsheet. So you have the cells which can change, and you have formulas like here you have b1 multiplied with b2, etc. And it creates the result. That is the data constructed from the combined state. So we can combine these cells and get an end result. And in this case, we can use the save state handler to preserve the original state for us, and then we can use them as flows and combine them as we wish. Now, what we can do with this is use this for validation, for example. So each time the username is changed, in this case, you could even modify it with two-way data binding. If the username changes, then the evaluated enable state is immediately resolved. Or you can do something much more crazy, like, for example, manage your state reactively. So in this case, we have multiple mutable fields, of course, but they are all observable. The current query is provided from the save state handle, so it is persisted, but isLoading is not. It is specifically a separate mutable state flow. And what we can do now is use this query that we have as a flow. We can observe when it changes, and only when it changes. We can debounce it with flow operators. Each time it changes, we can set the isLoading to true. We can even load the data with flatmap latest whenever this query changes, and return that to our observer on the other side. We can cache this with state in. And once you have this, you can even evaluate a view state class that could potentially expose things like should show loading or should show error, things like that. And you would not need to copy anything in this view state. You just combine them and everything is provided to you declaratively. But you should always try to avoid the case where you have a base view model that exposes that it can only contain one particular type as a state. Instead, actually, yeah. So if you get this state, then if you have mutable live data directly initialized like this, then you cannot integrate against the save state handle, and you cannot use combiners. And what you will end up with instead is this one mega class state that you might try to parcelize, and it won't work. It will contain the data, it will contain transient states, it will either explode or it will create an infinite loading dialog. So this is bad for you. And in the end, instead of combining our states, we ended up having to deconstruct them manually with value, 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 copy, 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 instead of just getting the object and build it from our latest states. And one more thing to note is that if we have this base view model that restricts any view model in the app for any feature to have only one state, that is extremely restrictive, and it could cause you problems in the future. You probably don't want to share behavior with inheritance like this. It's kind of scary and it can cause problems. In this particular case, though, it would be possible to expose state as a state flow as long as it's not directly initialized as a variable, but as like an abstract val, and the combined variable and the combined flow could be exposed there. But even then, you're not really getting anything if you're from this abstraction, if you're not actually relying on view models as base view models and having only one output, which most people usually don't. So it's better to keep them separately. And we're reaching the end of the talk. You can use these reactive helpers. I was using them in these slides, and I use them as well. Mostly the RX one, but the other ones also work. There are other resources to look at which help with the flow integration and how to use safe state handle. And that's it. Does anyone have any questions?
Yeah, so I don't think we have questions yet. But
You don't have questions, but,
but
you can have questions. I'm here.
yeah, and yeah, we will wait for some time whether everyone for someone to get some questions maybe. In the meantime, I have one. So, what do you think is the main difference with the state in regards of state handling between the kind of the pre-Jetpack era and now with the Jetpack era?
Well, it's a bit tricky to answer that. Like originally you had activities and fragments, they held their state and they would use onSave instance state and onCreate to always recreate it even on configuration changes. Technically, we always had access to either retained fragments or the last custom non-configuration change, originally even the last non-configuration change, if you handled it correctly, to not have this problem. Like you could always preserve data across configuration changes. They even created loaders to do that, but they were kind of clunky, so they were forgotten quickly. But now the real differences, in my opinion, is the existence of view models. In general, they like with compose on the horizon, you either have the fragments managed lifecycle still and just use them as containers for composables, or you can use composables directly and just not use fragments at all. And if you don't use fragments, then someone has to manage that surviving configuration changes, restoring a state after process that. So for that, you do need all of these Jetpack tools. And when Navigation 2.1.0 made the nav backstack entry become a view model store owner, a safe state registry owner, a lifecycle owner, that's when you were like, wow, they want to replace fragments with this entirely. And with Compose, it makes even more sense that when you have the composable destinations, they would have their own view model store owners that exist as long as the composable needs to exist. And this is all managed. So I think it's a bit trickier. There are many parts to consider, but overall they solve one problem. Well, there are other Android X libraries that solve other problems, but this batch of them solves this specifically, the ability to observe state changes. And I think we have come far with that. Like the very first scenario when Room introduced observable queries, if you had used Realm before that, like in 2016 and 15, then this wasn't new to you. But with Room, this all of these good things, observable queries, evaluated on a background thread in Room's case, which was even more nice, you got a lot. Like this was really helpful, especially how it observes the tables that change and even joined tables. This isn't something you want to do by hand. It's really nice how they provide the what's it called? Yeah, so it's really oh yeah, the annotation process, of course, so that they actually generate this code for you so that you don't have to do it yourself. So yeah, a lot of Jetpack libraries are nice.
Yeah, in the meantime, we received a bunch of questions. So
Oh, nice. Let me see.
Please take them one by one.
Okay. So how can you write tests for state-saving restoration logic? You can actually instantiate the safe state handle, so you could test your interactions with that. But when you're actually testing process that, I think there are two things you can do. You can either do what I said in the talk, go to the screen, put it in background, terminate it, and relaunch it. But there's also a library called Venom, which adds a notification that if you press it, then it kills your app in such a way that it would that it would come back after process that. And that's actually really nice because you can test that. But that is also manual. Like there is no real other way that I know of that would test for like parcelables being restored after process that. Like I mentioned multiple times that parcelable objects that are mutable being passed as arguments can do extreme damage. Like you can debug them for 3 hours. There was a case, and I actually debugged this case for 3 hours in someone else's code because you're like, why can this change? And it was an array list of a parcelable from another screen. So that would only be a copy when Android recreates it. So you have this bug that only happens if you haven't encountered process that yet. So that's like the inverse of everything that causes you problems. That's why you don't really want these mutable variables. Will the slides be made available after the event? Yes, I'm going to upload them to SlideShare, and I'm going to spread it on Twitter.
Yeah, wait a little bit. This is the app that you mentioned, right? I pasted it in the chat. Just if you can verify.
Check. Yes, that's the one.
Yeah, for testing process test, right?
Yep.
Manually.
I haven't really used it, but they said it works, and I trusted them. So it makes sense. Like what they do makes sense.
Okay. So back to the questions.
So I think if you're using safe state handle and stuff, what you want to do is like passing your own and see what's in there with like get and set, because you can generally trust it. But if you try to save types that are not, like for example, array lists, they are, because of type erasure, they cannot tell ahead of time it's if a parcel or a serializable or a string or something else completely that they cannot serialize. So that would explode.
And Chongo, thanks for the other link. That's also useful. Gábor also mentioned that in his talk.
Yes. That is a useful application. I love it. Can you test process that in an automated way? I have heard that is the holy grail, and and I am not aware of it at this time.
Yeah.
Gábor, you showed us a lot of useful methods. What do you use in a general fragment? It depends on whether you're using Rx or live data or flow. They are pretty much all the same. Like you can use behavior relays instead of mutable state flows, instead of mutable live data. It doesn't really matter in that case. It's different API. You interact with different things. They have slightly different quirks. So so what I generally use, if I have that option, I actually still like Rx. I'm one of the apostates who still uses Rx Java because it's just so predictable. You don't need to consider things like the exception bubbling in coroutines if you're really unlucky, or supervisor jobs and whatnot. Like, so I like Rx, but we only use a minimal subset of the Rx operators. What else do you use in a general fragment? Like you did see the slide, the one with the fragment on it. That's technically the basis that you want when you're using Jetpack. Like you want by view models, you get it in onViewCreated, you define the observers inside onViewCreated. If you have too many of them, make local methods or local functions inside onViewCreated. You don't need to make them like private functions. You can even just use local functions. It will still provide you with the categorization. I use that a lot in my compose samples. So yeah, in that case, it depends. If you're using flow, then you use launch when created. You probably will want to use the add repeating job instead when it stops being alpha. And with Rx, you just like use composite disposables, you make the subscriptions. With live data, you make the observes, and you don't do much else inside the fragment. Everything else pretty much happens in the view model. I hope that answers that. Okay, I believe we won't need view models for Jetpack Compose. Good luck with that. Do you see any use case for them? Yes. Surviving configuration changes and navigating between composables. Like when you navigate away from a composable, it gets removed entirely. It stops existing. It's not a thing. So you need something that tracks the state, like not only just the back navigation state, because that's obviously just a list in, let's say that it is just a list of string destinations, for example, like in the case of actually navigation compose, but you still want to survive, not process that saveables handle that, but you do want to survive configuration changes. So it does provide you with the local view model store owner. The Jetpack navigation sets it up for you. You can also do it yourself, but it's tricky. If you're doing it yourself, like I have a library that I haven't mentioned before, which is basically a competitor for Jetpack, but there I also manage that things stay alive according to navigation state. You cannot really avoid that, and so either Jetpack navigation or something similar, either view model or something similar will be needed in order to survive configuration changes. That's what I think. When I showed the compose slide, I was talking to what's basically a view model which exposed its state for reading, and it was passed directly into the composable. And the composable knew nothing about where the data comes from. And this allows us for better reusability, for example.
Yeah, and don't be shy to plug your library. It's the simple stack, right?
Yes, it is.
Yeah, I will paste it in the chat, and in the while I also pasted two useful links for handling state with Jetpack Compose. You can see there how the view models can be used or needs to be used for that.
Yep. What should we do to prevent transaction? Too large exception. Don't store too much state in the onSave instance state bundle. Reload the data asynchronously based on your state. You have a lot of tooling to help you with that. You can either use like coroutine live data. You can use mutable state flow and flatten playtest. You can use RxJava's observables and switch map. They let you observe the changes of the state and load things asynchronously. Asynchronicity just becomes a simple method call. In the case of suspend functions, so coroutines, it even just becomes a keyword. So at that point, you can load it based on your minimal representation and try not to save large things, especially don't save bitmaps. Like bitmaps are big. They will not survive in a bundle. So that's basically my advice. Just try to minimize the amount of things you put in there. Save what's needed and not too many things. It shouldn't save large lists of data, and you shouldn't save bitmaps.
Okay, so I think, yeah, we can consider that one answered as well. Yeah. Yeah, and I think we reached the end. Thank you very much, Gábor. Thanks for your presentation. It was interesting as always.
I'm glad. I think I went a bit over time, but hopefully that was still okay.
Yeah, no worries. It was interesting.
Nice.
Still, so. Yeah. Let's wait a little bit. I will have some closing slides in a while.
There's a new question, actually.
Okay, go ahead with the question in the meantime.
Any strategy or architectural pattern which could help in figuring out accidental state mutation? That's a good question. You would probably need to use lints, but I actually just use my eyes, which is okay if you can like see enough of the code, but if you would have like these,
yeah, that's a good architectural pattern.
Like, not happen. But, okay, so that's just tools. So so I think it would be the lints that should help us with this, like not just a pattern. Like MVI is technically MVVM, but with more constraints that are questionable. I think MVVM is technically...
Don't get into the weeds, but yeah.
Oh, okay.
Don't get into the weeds with that one.
Sorry. Okay, it's fine. Like, what matters here though is that as long as your state is observable and combinable, you can avoid the state mutation. Like, but to actually detect if it changes in such a way that you don't expect it, I think that would be automated tooling. And I don't know of such a thing, but it might exist. until then, just be vigilant and do not expose array lists as either inside data holders or as public function return values, because that's always a recipe for disaster.